Data handling. Introduction. In our previous classes, you have dealt with various types of data. You have learned to collect data, tabulate and put it in the form of bar graphs. The collection, recording and presentation of data help us organize our experience and draw inferences from them. In this chapter, we will take one more step towards learning how to do this. We will come across some more kinds of data and graphs. We have seen several kinds of data through newspapers, magazines, television and other sources. You also know that all data gives us some sort of information. Let us look at some common forms of data you will come across as shown below. What do these collections of the data tell you? For example, you can say that the highest maximum temperature was in Jammu on 20 June 2006. Or we can say that on Wednesday, no child was absent. Can we organize and present this data in a different way so that their analysis and interpretation becomes better? We shall address such questions in this chapter. Collecting data. The data about the temperatures of the cities can tell us many things, but it cannot tell us the city which had the highest maximum temperature during the year. To find that, we need to collect data regarding the highest maximum temperature reached in each of these cities during the year. In that case, the temperature of the chart of one particular date of the year, as given in table 3.1 under subsystem. This shows that the given collection of data may not give us a specific information related to the data. For this, we need to collect data regarding in mind that specific information. In the above case, the specific information needed by us was about the highest maximum temperature of the cities during the year, which we could not get from table 3.1. Thus, before collecting data, we need to know what we could use it for. Given below are a few situations. You want to study the performance of the class in mathematics, performance of India in football or in cricket, female literacy rate in a given area, or the number of children below the age of 5 in families around you. What kind of data would you need in above situations? Unless and until to collect the appropriate data, you cannot know the desired information. What's the appropriate data for each? Discuss with the friends and family and identify the data would you need from each. Some of its data is easy to collect and some difficult. Organization of data. When we collect data, we have to record and organize it. Why do we need to do that? Consider the following example. Mrs. Seelam, class teacher, wanted to find how children had performed in English. She writes down the marks obtained by the students in the following way. In this form, the data was not easy to understand. She also did not know whether her impression of the students matched their performance. Neelam's college helped her organize the data in the following way. In this form, Neelam was able to know which student has got how many marks. But she wanted more. Deepika suggested another way to organize this data. Now, Neelam was able to see who had done the best and who needed help. Many kinds of data we come across are put in tabular form. Our school rolls, progress report, index in the notebooks, temperature record, and many others are in the tabular form. Can you think of a few more data that you come across in the tabular form? When we put a data into the proper table, it becomes easy to understand and interpret. Representative values. You might be aware of the term average and would have come across statements involving the term average in your day-to-day life. Isha spends on an average of about 5 hours daily for her studies. The average temperature at this time of the year is about 40 degrees Celsius. The average age of the pupils in my class is 12 years. The average attendance of students in the school during the final examination was 98%. Many more of such statements could be there. Think about the statements given above. Do you think that the child in the first statement studies exactly for 5 hours daily? Or is the temperature of the given place during the particular time always 40 degrees? Or is the age of the pupil in class 12 years? Obviously not. Then what do these statements can tell you? By average, we understand that Isha usually studies for 5 hours. Of some special, she may study for less number of hours and on the other days she may study late. Similarly, the average temperature of 40 degrees Celsius means that very often the temperature at this time of the year is around 40 degrees Celsius. Sometimes it may be less than 40 degrees Celsius and at other times it may be more than 40 degrees Celsius. Thus, we realize that average is the number that represents or stores the central tendency of the group of observations of data. Since average lies between the highest and the lowest value of the given data, so we say average is the measure of the central tendency of the group of data. Different forms of data needed different forms of representative values, a central value to describe it. One of the represented values is the arithmetic mean. You will learn about the other representative values in the later part of the chapter. Arithmetic mean. The most common representative value of a group of data is arithmetic mean or the mean. To understand this in a better way, let us look at the following example. Two vessels contain 20 liters and 60 liters of milk respectively. What is the amount that each vessel would have if both share the milk equally? When we ask this question, we are seeking the arithmetic mean. In the above case, the average of the arithmetic mean would be total quantity of milk by number of vessels equals to 20 by 60 liters is equal to 40 liters. Thus, each vessel would have 40 liters of milk. The average or the arithmetic mean AM or simply mean is defined as follows. Consider these examples. 1. Ashish studies for 4 hours, 5 hours and 3 hours, respectively on 3 consecutive days. How many hours does he study daily on an average? Solution. The average study time of Ashish would be total number of study hours by number of days for which he studied equals to 4 plus 5 plus 3 by 3 hours is equal to 4 hours per day. Thus, we can say that Ashish studies for 4 hours daily on an average. 2. A batsman scored the following number of runs in 6 innings. Calculate the mean runs scored by him in an inning. Solution. Total runs is equal to 36 plus 35 plus 50 plus 46 plus 60 plus 55 equals to 82. To find the mean, we find the sum of all these observations and divide the number of observations. Therefore, in this case, 282 by 6 is equal to 47. Thus, the mean runs scored in an inning are 47. Where does the arithmetic mean lie? You will find that the mean lies in between the greatest and the smallest observations. In particular, the mean of two numbers will always lie between the two numbers. For example, the mean of 5 and 11 is 5 by 11 by 2 is equal to 8, which lies between 5 and 11. Can you use this idea to show that between any two fractional numbers, you can find as many fractional numbers as you like? For example, between 1 by 2 and 1 by 4, you have their average 1 by 1, 1 by 2 plus 1 by 4 by 2 equals 3 by 8, and then between 1 by 2 and 3 by 8, you have the average 7 by 16 and so on. Range. The distance between the highest and the lowest observation gives us an idea of the spread of the observations. This can be found by subtracting the lowest observation from the highest observation. We call the result of the range of the observation. Look at the following example. 3. The ages of the years of 10 teachers of the school are 1. What is the age of the oldest teacher and that of the youngest teacher? 2. What is the age of the ages of the teachers? 3. What is the mean age of these teachers? Solution. 1. Arranging the ages in ascending order, we get 23, 26, 28, 32, 33, 35, 38, 40, 41, 54. We find that the age of the oldest teacher is 54 years and the age of the youngest teacher is 23 years. 2. Range of the ages of the teachers equals to 54 minus 23 equals to 31 years. 3. Mean age of the teacher equals to 23 plus 26 plus 28 plus 32 plus 33 plus 35 plus 38 plus 40 plus 41 plus 54 by 10 years equals to 35. 0 by 10 years equals to 35 years. Mode. As we have said, mean is not the only measure of central tendency or the only form of representative value. For different requirements from the data, other measures of central tendencies are used. Look at the following example. To find out the weekly demand from different sizes of the shirt, a shopkeeper kept records of sales of sizes 90 cm, 95 cm, 100 cm, 105 cm and 110 cm. Following is the record of the week. If he would find that mean number of shirts sold, do you think that he would be able to decide which shirt sizes to keep in stock? Mean of total shirts sold equals to total number of shirts sold equals to number of different sizes of shirts equals to 105 by 5 equals 21. Should he obtain 21 shirts of each size? If he does so, we will be able to cater from the needs of the customers. The shopkeeper, on looking at the record, decided to produce shirts of sizes 95 cm, 100 cm, 105 cm. He decided to postpone the procurement of the shirts of other sizes because of the small number of buyers. Look at second example. The owner of the ready-made dress shop says the most popular size of a dress I sell size 90 cm. Observe that here also, the owner is concerned about the number of shirts of different sizes sold. She is however looking at the shirt size that is sold the most. This is another representative value from the data. The highest occurring event is the sale of size 90 cm. This representative value is called the mode of the data. The mode of a set of observation is the observation that occurs most often. 4. Find the mode of the given set of numbers. 1, 1, 2, 4, 3, 2, 1, 2, 2, 4. Solution. Arranging the numbers with same values as together, we get 1, 1, 1, 1, 2, 2, 2, 2, 3, 4, 4. Mode of its data is 2 because it occurs more frequently than other observations. Mode of large data. Putting the sum of the observations together and counting the name is not easy if the number of observations is large. In some cases, we tabulate the data. Tabulation can begin by putting tally marks and finding the frequency, as you did in the previous class. Look at the following example. 5. Following are the margins of victory in the football matches of the league. Find this mode of the data. Solution. Let us put data into the tabular form. Looking at this table, we can quickly say that 2 is the mode, since 2 has occurred the highest number of times. Thus, most of the matches have been won with a victory margin of 2 goals. 6. Find the mode of the numbers. Solution. Here, 2 and 5 both occur 3 times. Therefore, they both are the modes of the data. Whereas mean gives us the average of all observations of the data, the mode gives an observation which occurs most frequently in the data. Let us consider the following examples. You have to decide upon the number of chapatis needed for 25 people called for a feast. B. A shopkeeper selling shirts has decided to replenish her stock. C. We need to find the height of the door needed in our house. D. When going on a picnic, if only one fruit can be bought from everyone, which is the fruit that we would get? In which of the following situations can we use the mode as a good estimate? Consider the first statement. Suppose the number of chapatis needed by each person is 2, 3, 2, 3, 2, 1, 2, 3, 2, 2, 4, 2, 2, 3, 2, 4, 4, 2, 3, 2, 4, 4, 3, 2, 5. The mode of the data is 2 chapatis. If we use mode as the representative value for this data, then we need 50 chapatis only. 2 for each of the 25 persons. However, the total number would clearly be inadequate. Would mean be an appropriate representative value? For the third statement, the height of the door is related to the height of the person using that door. Suppose there are 5 children and 4 adults using the door, and the height of each of the 5 children is about 135 centimeter. The mode of a height is 135 centimeter. Should we get a door that is 144 centimeter high? Would all the adults be able to go to the door? It is clear that mode is not the appropriate representative value for this data. Would be an appropriate state value here? Why not? Which representative value of height should be used to decide the door height? Similarly, analyze the rest of the statements and find the representative value useful for that issue. Median. We have seen that in some situations, arithmetic mean is an appropriate center of central tendency, whereas in some other situations, what is the appropriate measure of central tendency? Let us now look at another example. Consider a group of 17 students with the following heights in centimeter. The game's teacher wants to divide the class into 2 groups so that each group has equal number of students. One group of students with a height lesser than a particular height, and the group of students with higher greater than all. What should we do that? Let us see if the various options she has, she can find the mean. The mean is 113.5. So, if the teacher divides the students into 2 groups on the basis of this mean height, such that one group has students of height less than the mean height and the other group has students with height more than the mean height, then the groups would be of unequal size. They would have 7 and 10 members respectively. 2. The second option for her is to find mode. The observation with highest frequency is 115 centimeter, which would be taken as mode. There are 17 children below the mode and 10 children in the world above the mode. Therefore, we cannot divide the group into 10 equal parts. Let us therefore think of an alternative representative value of measure or central tendency. For doing this, we again look at the given heights in centimeter of students and arrange them in ascending order. The middle value in this data is 115 because this value divides the students into two equal groups of 8 students each. This value is called as median. Median refers to the value which lies in the middle of the data with half of the observations above it and the other half below it. The game's teacher decides to keep the middle student as the referee in the game. Here, we consider only those cases where number of observations is odd. Thus, in the given data arranged in ascending or descending order, the median gives us the middle observation. Note that in general, we may not get the same value for median and mode. Thus, we realize that mean, mode and median are the numbers that are the representative values of the group of observations or data. They lie between the minimum and maximum values of the data. We are also called the measures of the central tendency. 7. Find the median of the data. Solution. We arrange the data in ascending order. We get 17, 18, 24, 25, 36, 36, 46. Median is the middle observation. Therefore, 25 is the median. Use of bar graphs for different purposes. We have seen last year how information could collected be. First, arrange it in the frequency distribution table, and then this information could be put as a visual representation in the form of pictographs or bar graphs. You can look at the bar graphs and make deductions about the data. You can also get information based on these bar graphs. For example, you can say that the mode is the longest bar if the bar represents a frequency. Choosing a scale. We know that the bar graph is a representation of numbers using bars of uniform. Width and the length of the bars depend upon the frequency and the scale you have chosen. For example, in a bar graph where numbers in units are to be shown, the graph represents 1 unit length for one observation and it has to show numbers in tens or hundreds. 1 unit length can be represented in 100 observations. Consider the following examples. 8. 200 students of 6th and 7th classes were asked to name their favorite color so as to decide upon what should be the color of the school building. The results are shown in the following table. Represent the given data on the bar graph. Answer the following questions with the help of the bar graph. 1. Which of the four most preferred color and which is the least preferred? 2. How many colors are there in all? What are they? Solution. Choose a suitable scale as follows. Start the scale at 0. The greatest value in the data is 55. So, in the scale, at the value greater than 55 and use as 60. Use equal divisions along the axis such as increments of 10. You know that all the bars would lie between 0 and 60. We choose the scale such that the length between 0 and 60 is neither too long nor too small. Here we take 1 unit for 10 students. We then draw a level the graph as shown. From the bar graph we conclude that 1. Blue is the most preferred color because the bar representing blue is the tallest. 2. Green is the largest preferred color because the bar representing green is the shortest. 3. There are 5 colors. They are red, green, blue, yellow and orange. 9. The following data gives total marks out of 600 obtained by the 6 children of the particular class. Represent the data on a bar graph. Solution. 1. To choose an appropriate scale, we mark equal divisions taking increments of 100. Thus, 1 will represent 10 marks, What would be the given difficulty? We choose one unit to represent 10 marks. 2. Now represent the data using bar graph. Drawing double bar graph. Consider the following two collections of data. Giving the average daily hours of sunshine in two cities, Amradin and Margate, for all the 12 months of the year. These cities are near the South Pole and hence have only few hours of the sunshine each day. By drawing individual bar graphs, you would answer the questions like 1. In which month the city has maximum sunlight, or 1. In which months does each city has minimum sunlight? However, to answer questions like in a particular month, which city has more sunshine hours, we need to compare the average hours of sunshine of both the cities. To do this, we will learn to draw what is called the double bar graph, giving the information of both cities side by side. This bar graph shows the average sunshine of both the cities. For each month, we have two bars, the heights of which give the average hours of sunshine in each city. From this, we can infer that each, except from the month of April, there is always more sunshine in Margate than in Aberdeen. You could put together a similar bar graph for your area of the city. Let us look at another example more related to us. 10. A mathematics teacher wants to see whether the new technique of teaching she applied after quarterly test was effective or not. She takes the scores of 5 weakest children in the quarterly test and the halfly year test. Solution. She draws the adjoining double bar graph and finds a marked improvement in most of the students. The teacher decides that she could continue to use the new technique of teaching. Can you think of a few more situations where you could use double bar graphs? Chance and probability. These words often come in our daily life. We often say there is no chance of it raining today, and also say things like it is quite probable that India will win the World Cup. Let us try and understand these terms a bit more. Consider the statement: the sun coming from the west, and I am going to 3-meter height. If you take a cube of planet volume, its size will also be larger. If you take a circle that is area, that is straight, it will also be larger. India winning the next 3 cities. If you look at the statements given above, you would say that the sun coming from the west is impossible. An ant growing to 3 meters is also not possible. On the other hand, if the circle is of larger area, it is certain that it will have a larger area. You can say the same about the large volume of the cube and the larger side. On the other hand, India can win the next test series or lose it. Both are possible. Chance. If you toss a coin, can you always correctly predict that you will get? Try tossing a coin and predicting the outcome each time. Write our observations in the following table. Do this 10 times. Look at the observation outcomes. Can you see the pattern in them? What do you get after each head? Is that you get head all the time? Repeat the observation for another 10 tosses and write the observations in the given table. You will find that the observations show no clear pattern. In the table below, we give you observations, generally in 25 tosses by Sushila and Salman. Here, H represents the head and T represents tail. What does this data tell you? Can you find a predictable pattern from head and tail? Clearly, there is no fixed pattern of occurrence of head and tail. Would you throw the coin each time? The outcome of every throw can be either head or tail. It is a matter of chance that in one particular throw you get either of these. In the above data, count the number of heads and the number of tails. Throw the coin some more times and keep recording what you obtain. Find out the total number of times you get a head and the total number of times you get a tail. You also might have played with a die. The die has 6 faces. When you throw a die, can you predict the number of that will be obtained? While playing Ludo or Snake and Ladders, we have often wished that in a throw you get a particular outcome. Does the die always fall according to our wishes? Take a die and throw it in 150 times and fill the data in the following table. Mark a telemark. Each time you get the outcome against the appropriate number. For example, in the first throw you get 5. Put a tally in front of 5. The next throw gives you 1. Make a tally from 1. Keep on putting tally marks for the appropriate number. Repeat this exercise 150 throws and find out the number of each count from 150 throws. Make bar graph using the above data showing number of times 1, 2, 3, 4, 5, 6 have occurred in the data. What is probability? We know that when a coin is thrown, it has 2 possible outcomes, head or tail. And for a die, we have 6 possible outcomes. We also know from experience that for a coin, head or tail is equally likely to be obtained. We say that the probability of getting head or tail is equal to 1 by 2 of each. For a die, possibility of getting either 1, 2, 3, 4, 5 or 6 is equal. As for a die, there are 6 equally likely possible outcomes. We say that each of our 1, 2, 3, 4, 5, 6 has 1/6 probability. We will learn about this in the later classes. But from what we had done, it may perhaps be obvious that events have that more possibilities can have probability between 0 and 1. Those which have no chance of happening where probability is 0 and those have want to have probability 1. Given any situation, we need to understand the difference, possible outcomes and study the possible chances for each outcome. It may be possible that the outcomes may not have equal chance of occurring, unlike the cases of coin and die. For example, if a container has 15 red balls and 9 white balls, and if a ball has pulled out without seeing, the chances of getting a red ball are much more. Can you say why? How many times are the chances of getting a red ball than getting a white ball? Probabilities for both making 0. What have we discussed? 1. Collection, recording, and presentation of data help us organize our experiences and draw inferences from them. 2. Before collecting data, we need to know what we use for. 3. The data is collected needs to be organized in a proper table so that it becomes easy to understand and interpret. 4. The average is the number of that represents or shows the central tendency of the group or observations of data. 5. Arithmetic mean is one of the representative values of data. 6. Mode is another form of central tendency or representative value. The mode of set of observations is the observation that occurs most often. 7. Median is also a form of representative value. It refers to the value which lies in the middle of the data with half of the observations above it and the other half below it. 8. A bar graph is a representation of numbers using bars or uniform widths. 9. Double bar graphs help to compare two collections of data in graphs. 10. There are situations in our life. There are certain to happen. Some that are impossible and some that may or may not happen. The situation that may or may not happen has a chance of happening.